All right. Welcome to the concluded part of gases law. Right. So we looked at Boyle's law and Charles's law. Boyle's law and Charles's law basically look at the physical properties of gases. So we have these two laws that evaluate the chemical properties of gases when they react together. So the first one we're looking at today is the Gay-Lussac's law of combining volumes. Law of combining volumes look at what happens when why there's also Avogadro's law, or Gay-Lussac's law of combining volumes. So I'm going to just show you a slide and pick it from there. So from this slide, you could see that in the formation of ammonia is NH3, right? Is a popular chemical. So we have two gases reacting together. We have nitrogen gas and hydrogen gas. So it takes one volume of nitrogen gas to combine it with 3 volumes of hydrogen gases to form 1 volume of ammonia. All right. So this is what Gay-Lussac's law is about. That when gases react together, they do so in whole numbers. In whole numbers that bear simple ratio to one. Every volume for every 1 volume of ammonia form, there is a requirement of 1 volume of nitrogen gas, right? With 3 volume. So if we have 2 volume of nitrogen, that means we need how many volume of hydrogen, please? If 1 is to 3, then 2 will be to what? Of course, to 6. So 1 to 3, 2 to 6, and then you can do this ratio between the reactant or between the product if it is gaseous. Like in case of ammonia, so one volume of nitrogen is required for 1 volume of ammonia gas. Okay, while 1 volume of hydrogen, while 3 volume of hydrogen, excuse me, is required for 1 volume of ammonia also. All right, so that's what you should just basically focus on, and let's look at today. So the statement of Gay-Lussac's law is that gases react in simple whole numbers, right? They react in volumes that that are in simple ratio to whole numbers, and this is considering that temperature and pressure remains constant. So at constant temperature and pressure, gases react in volumes. They are bare simple ratio to one another and to the product if it is gaseous. So because in some cases the product may not be gaseous, okay, but if two gases are simple whole number, okay. So let me show you another action. So looking at this illustration, you can see that if each flask represents a volume, so we have 2 volumes of hydrogen reacting with 1 volume of oxygen to produce 2 volume of water. Okay, so 2 volumes of hydrogen reacting to, so that is just what Gay-Lussac's law is about. All right, so and remember that volume, the unit for volume is centimeter cube. So for 2 volumes of hydrogen means 2 cm cube reacting with 1 cm cube of oxygen to produce 2 cm cube of water. Okay, so that is what Gay-Lussac's is about. The statement can also be understood from the perspective of, this is example of volumes. Okay, so at constant temperature and pressure, we have gases in ratio of volumes of small whole numbers. So that's what it gives us. So you can focus on the but what you should understand is combine in volumes that bear simple ratio to one another. All right, this can be understood from, so that means for us to actually understand this, we have to consider the balanced chemical equation of for any gases that are reacting together, for us to know, okay, this volume reacts with this volume to get this volume. Okay, so using that relationship, we can find what amount is required for one gas to be produced, or what amount is required for one gas to react to another gas. Okay, let's quickly look at an example based on this, or let's just do a quick workout. I would like you to at some point pause the video and try to get this. If 2 volumes of hydrogen react to 1 volume of oxygen to produce 2 volumes of water, what amount of oxygen will be required to react with 10 volume of hydrogen? Pause the video at this point and try to get 10 volume of hydrogen will require how many volume of oxygen? Remember that 2 is to 1, then 10 will be to what? Okay, if you're right, that will be 5, because 2 is to 1, 4 is to 2, 6 is to 3, like that. That's just a ratio thing you're going to do. And if you're dealing with water, 2 is to 2, so 4 is to 4, so it is like ratio 1 to 1. So that's what Gay-Lussac's law is about. So let's look at an example. An example solved. Then I have an example here. So you say calculate the volume of oxygen required to burn completely this amount, this volume of hydrogen to produce steam. Steam is the gaseous state of water, and what gas law is applicable? Okay, of course, we first have to get a balanced chemical equation of reaction from which shows that 2 volume of hydrogen react with 1 volume of oxygen. So when you have a question like this, you focus on the two reagents or reactants or products that have been compared. In this case, we are comparing oxygen with hydrogen. So what volume of oxygen is required? So just focus on oxygen and hydrogen. But steam is mentioned, but we're not looking at what is produced or required. So if 2 volume of hydrogen requires 1 volume of oxygen, 82 cm cube, so you just do a quick required volume of gas. So 2 cm of cube of hydrogen of oxygen. So like I saw explaining ratio of you can first calculate for one cm cube because that make it easy. Okay? So that's what I did here. So if 2 cm cube require 1, that means 1 require 1/2. So I can then use this 1/2 to multiply 82. It's suitable for you, but actually a very easy one for me, and I think it's gonna work for you also. Just basically amount. So that's what was done here. So that therefore 82 cm cube of hydrogen requires how many? 41 of oxygen. Okay. And of course, the law applicable is again Lusac's law of combining volumes. That's the law that is applicable to chemical reaction between gases when it comes to gas laws. Okay, so we have a before you're gonna have your own assessment. So it says 50 cm cube of carbon 2 oxide was exploded with 150 cm cube of air. Right, remember that air is a mixture of gas. So there are basically about 2 major gases in air, if you know. So we have oxygen and nitrogen in air. So containing 20% of oxygen by volume. So the question is calculate the volume was in excess and by how much. Okay, this question requires a little bit of deep thinking. First, in air, when you say it was exploded with 150 cm of air containing, so carbon 2 oxide basically does not react with all the gases in air. It reacts with only oxygen. That's why oxygen was mentioned. The amount of oxygen was mentioned. So in the volume of air, is 150 cm cube. But in this 150 cm cube, only 20% is oxygen. So first, it will be required that we get 20% of oxygen, 20% of 150 cm cube, excuse me. So when we get that, we'll know what amount of oxygen is reacting with what amount of the carbon 2 oxide. But also you need to also get the balanced chemical equation, which in most cases you'll be given. So for CO2 and oxygen, so you have CO2 is actually O, as CO, carbon 2 oxide is CO, is reacting with O2. So we write the balanced chemical equation with O2, and then the product is carbon 4 oxide. Okay, so it produces CO2. So when CO reacts with CO2, you have CO2. So to balance the chemical equation, you have to understand that excuse me. Okay. To balance the chemical equation, you will see that you have 2 CO2 in the end plus O2. Okay. All right. So looking at the solutions to this quickly, so you see 2 CO2 plus O2 gives 2 CO2. So this is the balanced chemical equation, and this is the amount of oxygen in 150 cm cube of water. So the amount is 30 cm cube. So from that equation, you see that first you could see that from balanced chemical equation, 2 volume of CO requires 1 volume of oxygen. So, but the amount of oxygen available in 150 cm cube of air is 30 cm cube. Okay, using that relationship, we can decide that 2 cm cube of CO requires 1 cm cube. So like I said again, I'll first find for 1 cm cube, that's half, multiply that by, so 50 cm cube of CO will add 1 half of 50, but note that there was 30 cm cube of oxygen gas. So if you could see that the volume of residual gas is the gas that is not unreacted plus the volume of CO2. So it is, we don't have we have 30 cm cube of oxygen gas. So it's only 25 cm cube that is required to react with it. So that's why we have the excess gas as 5 cm cube. Okay, so just go through the lesson all over again, and you should understand that. Then try these questions out. Right, try this question. I've given you the balanced chemical equation, so solve this question in your notes. Right, solve this question in your notes. So before you write the notes, solve this question first and post a picture of it. But if you don't understand how to solve the question, we hold on till we have our next live section, then I'll walk you through it. All right, but go through this lesson, and when you're done with this lesson, your very first assignment that I will know that you have gone through this lesson, as soon as you're done, is to put the message on the attend channel in chemistry PG class what the statement of Lusac's law is. Put the statement right in that place. I really need to see it. Okay, bye.